Welcome to Professor's Chamber, and today we are going to be looking at differentiation of function of functions. That is, this one is simply like it's simple like it's not the same thing as product, it's not the same thing as quotient, but in this particular one, you can have a product rule inside, you can also have a quotient rule inside. So it's just simply when a function is inside a function, when a function is inside a function, maybe for example you have a trigonometry function inside an algebraic function, or you have an exponential function inside trigonometry function. It's not like it's really multiplying, but it is inside. As you can see, we have some few examples here. You can see that this is x squared plus 4, then everything is enclosed by what? By 5. You can't, now in differentiating this one, you can't just see that differentiation of this one is divide the x is equals to 5 into x squared plus 4. No, it's not correct. You can't say so. And in doing this one, you can't just differentiate it anyhow. So this kind of function is called function of function. As you can see, the sign x is inside of what? Of the logarithm function. The trigonometric function is inside the logarithmic function. So now if you have something like this, how do you do it? I'm going to give you a quick analogy. It's just like you have a house. You want to clean up a house. So now, you first thing you do is that you take out the things in that room, or sorry, you want to clean up a room. So in cleaning up a room, what you first thing you do is what you take out every property that is in that room. You take it out. So once you take it out, you clean those property outside, then you clean the room itself. So now let's take the cleaning to be the derivative, or the differentiation. Now let's take this as example. Let's say we have that our y is equal to x squared plus 4 raised to the power 5. So now take this one as the property inside this is the whole room, you understand, but take this one as the property inside the room. So you take it out. So now taking it out, you can say let u be equal to x squared plus 4. Okay, so now which means that you now say you find the derivative of this, that is your du. You find your du dx, which is now going to be 2x. Then the derivative of 4 is 0 because it's a constant value. Okay, so not necessarily that it must be u. You can use other value. You can use w, you can use y, you can use w, you can use v, you can use a, you can use b, the one that you think is convenient for you. So just make sure that you are letting. Okay, so when you're done with that, you now discover that your y will now be u raised to the power of 5. Okay, this is the room now. So this is the property in the room. So you've taken it out and you've cleaned it. Cleaning it is finding a derivative now. So you want to clean the room now. So it's going to be, now that means you want to find the derivative of this. So it's going to be dy du will be equal to what? That is 5u raised to the power of 4. Okay, so you have done it. So finally, what you're now going to do is that you're going to say your dy dx will now be equal to this multiplied by that. Is you are bringing back everything together. So it's going to be dy du multiplied by du dx. So your dy dx will be equal to, what's your dy du? Your dy du is 5u raised to the power of 4 multiplied by your du dx. Your du dx is 2x. So dy dx will be equal to 10x u raised to the power of 4. So which means that, and don't forget that your u is what? Your u is x squared plus 4 raised to the power of 4. So that is for that. Then now let's go to the second example. You have your y is equals to in sine x. Okay, so now look at it. Now if I'm to solve this, I'm going to simply let this one, I'm going to take this one as the property inside the room, and I'm taking it out. So I'm going to let this one to be something for, I'll just say that I can say let v be equal to sine x. So which means I'm going to look for dv dx. So I'll say dv dx is equal to, you find the derivative of sine x. The derivative of sine x is cos x. So if you've not watched the video I made on differentiation of some basic principles, please go and watch it. It's very of some basic function rather. Please go and watch it. I'm going to leave a link below this video. Please make sure you go and watch it so that you can understand. You can understand proper. Okay. So now since you said your v is equal to sine x and your dv dx is cos x, so what you do now is you bring it back to this point. You now say your y will now be equal to in v, isn't it? And don't forget that in v is the same as log v base e. Don't forget, I already told you that in the video. You also see that one in the video also, in that video also. So once you have something like this, the dy, now you will now find your dy dv. Your dy dv will be 1 over v, because when you differentiate this one, you are going to have 1 over v. So finally, your dy dx will be equal to dy dv multiplied by what? Multiplied by dv dx. Now dy dx, sorry, will be equal to, what's your dy dv? Your dy dv is 1 over v multiplied by dv dx. Dv dx is cos x. Okay, so now your dy dx will be equal to cos x over v. What's v? V is sine x. So which is equal to, as you can see, cos x over sine x will give you what? Cos x over sine x is the same as cot x. So that is for that. Then for the final example, that we have that y is equal to cos into x. So okay, it's simple. So what you simply do is this. I'm going to simply say that I'll say v be equal to into x. Okay, now don't forget that this is now in this question. Now this question contains 3 functions. It contains number 1, this is trigonometric function, this is logarithmic function, and this is algebraic function. So first of all, just say let your v be equals to into x. And if you are differentiating, this is another example of function of function. So you simply say let u be equals to 2x. So which means that your du dx will be equals to 2. Then you come back, then your v will now be equals to in u. So now your dv du will be equals to what? 1 over u. That is when you differentiate in u, you have 1 over u. Okay, so now since you've done that, then finally you now discover that your y will now be equal to cos what? Cos v, because your v is what? Is in 2x. So your y will now be cos v, because you let the whole of this in 2x to be v, so your y will be cos v. Then you find the derivative. So your dy dv will now be equal to, when you differentiate cos v, you have minus sine v. Okay, so finally you just say your dy dx would now be equal to a combination of 3 things. Number 1, that is dy dv multiplied by dv du multiplied by du dx. So which means dy dx is equals to, what's your dy dv? Your dy dv is minus sine v, then multiplied by your dv dx is your dv du, sorry, is 1 over u, then your du dx is 2. So dy dx will be equal to minus sine, what's v? Your v is in 2x, then multiply by 1 over, what's u? U is 2x multiplied by 2. You use 2x, so this will cancel this, then dy dx will be equal to minus sine in 2x over x. So that is for that. Thank you very much for watching. Make sure, if this video has been is helpful to you, make sure you like, make sure you share, make sure you comment, and also don't forget to subscribe. Thank you.